let's start the lecture without wasting the time, right? And let's jump on to the new CCNA 301, which I am going to teach you as per the Cisco syllabus. All right.
Yeah.
So this is the Cisco website, and this is the course outline. Okay. So let's start with the network fundamentals, which is the 20% of the course. And I just want to ask you one thing, that should I go from very basic to the last thing, or should I teach you as per the this, like it is telling me to show you from the router?
Okay. It's up to you, mate. If you have like a better, smart way of content, way of presenting, I'm all good.
Yeah, so I have a better smart way of presenting there. Okay, so I'll go from my way so that you can understand each and everything. All right.
Yeah.
And we should not skip anything. All right. So
Yeah.
let's start the course and we'll go from very basic. So let's start from very basic. All right.
Yeah.
Which is called LAN. Okay. LAN stands for local area network, right?
Yeah.
So LAN stands for local area network. See, so now let's say you are facing the interview and I am the HR person, and I just ask you, okay, Dennis, you have that much of experience, you have a network engineer, you have done CCN and all. So please tell me what is LAN, right? So how you are going to tell me what is LAN in your words, not in my words?
LAN is local area network, which is like after the router or the modem connect like PCs together with a server or with a within like a switch.
Mm-hmm.
Switch. So you can use hub.
Mm-hmm.
Yeah, small area network.
All right. See, your answer is right. It is 100% right. But if you want to pass in the interview session, so your answer must be presentable, right? So this is
Yeah.
the wording. This is my personal wordings. So you can use these wordings in your interview. All right. So LAN stands for local area network. Two or more computers or communicating device, if they are in the same room or on the same floor or in the same building, if connected with each other, are said to be connected on LAN. And LAN devices are switch and hub. All right. And if
Yeah.
you want, you can take a screenshot also. Okay. If you have an option of a screenshot, then you can take a screenshot also. And plus, we have a recording also. All right.
Okay.
So you can watch the recording after the lecture and you can make notes of your. So let me explain you in brief. Say here. Let's say you have, in our room we have multiple computers and we are multiple people are staying in a one room or in a one office, and we have like this 8 computer or 100 computers in our room, right?
Yeah.
Okay. And so what I will do, I will just bring the switch. I will go to the market and I will just bring the switch. All right.
Yeah.
I will just bring the switch and I will connect all the computer to the switch. Right.
Hmm.
I will connect all the computer to the switch. Okay. Now it is said that if I connect all the computer in the same room, the criteria is in the same room. If I connect all the computer in same room, it is said that all the computers are connected in LAN. Got it?
Okay, so it should be on same room.
Yeah, it's criteria. Now I'm explaining more. Okay. But the LAN is not limited up to a same room. It can go up to the floor wise also. Let's say you are working in your office and in your office you have multiple floors, right? First floor,
Yeah.
second floor, third floor, fourth floor, fifth floor. So you have multiple floor in your office. Okay. So let's say you are working on the first floor and in first floor we have thousands of PCs, right?
Yeah.
And if I connect all 1,000 PCs with each other. So it is said that all the PCs on the same floor are connected on LAN. Okay.
Yeah.
Now the LAN is not limited up to a floor. It can go to building also. Let's say in this building you have multiple floors and you have connected all the floors with each other with the help of switch. Have you seen the switch, Cisco switch? Have you ever seen the Cisco switch? How switch
Yeah.
look like? All right, that's good. I think you're working as a network engineer also, right?
Telecommunication.
Yeah, telecommunication. So let me show you in a more deep way how the Cisco switch look like so that there must be an image in your mind, right? To give you a hands-on experience, let me show you how the Cisco switch actually look like. The switch whom which I'm talking about. So let me give you a hands-on experience about this. See, see, this is a layer 2 switch. I later on I will discuss what the difference between layer 2 and layer 3. Okay, now see this. You have seen this type of switch, right, in your office.
Yeah.
See, this is the layer 2 switch. Okay, model number 2960, and it is written on the switch. Okay, see, catalyst switch 2960. All right, and these are the ports. These are the ports where we connect the laptops, computers, printers, scanners. All right, whatever comes in the LAN, so we connect on this port. All right.
Yeah.
If we if we look at the back panel, if we look at the back panel, see that there is nothing in the back panel except the power, right?
Yeah.
This is power, right? Here we connect the power cord to give the power to our switch. All right. So this is the switch which is used in our LAN, okay, in our office, in a building, in a home, right?
Yeah.
Uh, So we are here. So the LAN is not limited up to a room or a floor. It can go up to the building wise also. If I connect all the computers in the whole building, then it is said that if first PC is able to communicate with the last PC of the building, so it is said that all the computers in the same building are said to be connected on LAN. All right. So this is
Okay.
what I am trying to saying you that LAN stands for local area network. Two or more computers or communicating device if they are in a same room or on a same floor or in a same building if connected with each other are said to be connected on LAN. Okay.
Okay. Yeah. Is it
Hmm.
more like it should be in the same subnet, isn't it? Like,
Yeah, it is a same subnet. Yeah, the LAN is in same subnet. The LAN must be in a same subnet.
yeah,
Okay,
because
until and unless we create the VLAN. In
yeah.
later on, I will show you why to create a VLAN and how to create the VLAN. It is there in the syllabus. All right.
Okay.
So this concept is clear. You can do one more thing also. If you have a mobile phone, then you can take the pictures also of the slide, so that after the lecture also you have a recording, but you have a screenshot as well, right? So it will be
Yeah.
benefit for you. Yeah, and it is totally depend upon you. If you are comfortable, then you can take the pictures also in your mobile phone, and later on you can just connect your mobile phone and make a folder of CCNA slide, right?
Yeah.
Yes. All right. So we have done the LAN, and the one important thing is in LAN we are using a switch, right? In LAN
Yes.
we are using a switch. So it means switch is a device which is used in a LAN, right? Switch is a
Yeah.
device which is used in a LAN, all right, and and it is in switch there are two types of switch, layer 2 switch and layer 3 switch, right? Later on I will
Yeah.
discuss what is the difference between layer 2 and layer 3. for time being, just understand that switch is a device which we use in our local area network to connect the computer locally, to connect the computer in a same network, right? Which
Yeah.
communicates in same network. All right.
Mhm. Layer three switch is a IP switch, is it? Like
Yeah,
network
yeah,
switch.
yeah. It is a IP switch. Layer 3 switch is a IP switch. Yes, you are right. All right. And layer 3 switch is also called as multi-layer switch, and it is working as router and switch both.
Switch both, yeah.
Yes, it working as both. All right.
Yeah.
So for right now, just understand that switch is used in our LAN, right? And
Yeah.
it provide communication within same network. All right.
Yeah.
All right. And this was the definition, right? Local area network. You can take picture of this also, so that
Yeah.
later on, local area network, right? Done. Now let's move on to the next topic, which is man. And recording is there. After the recording also, like you can take the screenshot while you are learning, right?
Yes.
Yeah, for right now, you just understand what I am trying to explain you. Okay, so
Yeah.
we have completed the LAN. So the outcome of LAN is we are using switch in a LAN. Okay, switch communicates in same network, right?
Yeah.
All right. And LAN means two or more computers or communicating device if they are in a same room or on a same floor or in a same building. If connected with each other are said to be connected on LAN. And LAN device are switch. So it means switch is a device which is used in LAN. Okay.
Yeah.
All right. Now see here. Okay. Now let's move on to the next subtopic, which is called MAN. MAN
Man.
stands for Metropolitan Area Network. All right.
Okay.
Now, MAN means like two or more computers or communicating device if they are in a same city but geographically connected with each other. If they are connected with each other and they are said to be connected on MAN. Let's say you are from Australia, right?
Yeah.
And in Australia, you are staying in which city?
But
Perth, right? See here. So let's say in Australia, you have two locations. Okay, you have two locations here. In Australia, you are sitting in a Perth, right?
yeah.
P-E-R-T. Okay,
PERTH.
P-E-R-T-H. Perth, right?
Yeah.
Now, Perth is a city, right?
Yeah.
Okay, now in Perth, please name the two places. In your city, please name the two places.
Just put it A and B or something like that.
Okay, let's say this is an A place and this is
Yeah.
a B place, right? B. So, what is the man definition is? Man says that two or more computers or communicating device which is geographically separated from each other but in a same metropolitan city if connected with each other are said to be connected on man. All right.
Okay. So one question, like in land, it cannot be separated from geographically. Like
Yes,
it can be
in LAN we cannot geographically separate it. LAN definition is same room, same building, same office,
same
same
office.
floor.
Okay. So
Yeah,
this
in
thing
man,
is like two buildings connecting through a virtual private network, like
yes,
something like that.
yes. So
But it
if you
should be
want
in
to
the
connect
same city,
if
isn't it?
yeah if you want to connect two buildings, which is nearby, like from like 1 kilometer distance only, then practically it is LAN, but theoretically it is MAN.
Okay.
All right. Practically it is LAN because they are using the same network, right?
Same.
But if you go theory wise, then theory says that LAN must be in a same building. If buildings are separated, then theoretically it is MAN. Practically it is LAN. Got it?
Yeah.
Now, so this A and B are geographically separated, but in a same city. In a same city, if is still connected with each other with the help of some network, so that network is called as MAN. All right.
Okay.
Okay. And the MAN device are router. Without router, you cannot communicate in WAN or MAN because because if you have a two branch offices which is
Mm-hmm.
at different location, so that branch office must be in a different network also. Let's say a branch office is in 192 network. Here the 192 network is running, and at B location 172 network is running. So
Yeah.
now if you want to communicate in two different network, then you have to use a device called router, because router is a device which communicate between networks and switch communicate within same network. Got it?
Yes.
Okay. So it means router is a MAN device. Router is a device which is used in your MAN or WAN. Because I am from India and you are from Australia, we are from different countries. So if you connect different countries or different cities, that comes under WAN.
Van. Yeah.
Okay. So the LAN means same office, same room, same building. MAN means two offices and it is geographically separated but in a same city. It must be in a same city, right? So if it is in a same city but at a different location and if it's still connected with each other on some network, so that network is called as MAN. All right.
Yeah.
Okay. So we have completed the LAN and we have completed the MAN. And one more thing about the MAN is if we have two branch offices, so that branch offices must be in a different network. And if you want to communicate in different network, so we have to use a device called router because router communicates between networks. All right.
Yeah.
Okay. So router communicates between networks. Now when I said you that when stands for wide area network, two or more computers or communicating device which is geographically separated from each other but in a different metropolitan city or in a different country, if connected with each other, are said to be connected on WAN. And WAN device are router, right?
Yeah.
All right. So it means like let's say I am staying in India and you are in Australia. So if we both are connected with each other, so we are connected on WAN. All right.
Yeah.
Okay. So we have completed the LAN, MAN, and WAN. All right.
All good, man.
Okay. So can I move up? Can I change the slide?
Yeah.
All right. You just like sit at a place where you don't make anything. Like some sound is coming. Like you are picking
Sound is
something
fine,
on
man.
your.
I can
Yes. Okay.
I can hear you
All
clearly.
right. Okay. Okay. All right. Okay. So here we are going to understand the Ethernet wires, the wires which is using in Ethernet. Okay.
Yeah.
Okay. Now, first of all, what is Ethernet? Ethernet is a technology. Ethernet is a technology. All right.
Yeah.
There are two types of technology. Let me explain you this thing. See here. There are two types of technology: Ethernet technology and serial technology. Okay.
I thought Ethernet was a serial technology.
Yeah. Now serial technology is no more. Earlier, internet was also working on serial, but right now, serial technology is no more. No one is using serial technology. Everyone is using Ethernet technology. And
Okay.
internet is also working on Ethernet technology, because on internet we are using fiber optic cable, and fiber optic cable comes under Ethernet technology.
Okay.
Got it? So internet is not working on serial technology. Earlier it is possible to use serial technology. Nowadays no one is using serial technology. So why I am teaching you this? Because in your syllabus we have a serial technology also, little bit. Okay?
All right.
All right. So there are two types of technology: Ethernet technology and serial technology. Now what is the difference between this? See, earlier what happened? Earlier Ethernet technology was not, let's say from starting, from where the communication was started in earlier days, like in 70s or in 60s or 80s. Okay, so earlier at that time what happened? Ethernet technology was fast, but it is not giving the long coverage. Okay,
Mm-hmm.
Ethernet technology was fast, but it is not giving the long coverage. So if we want to communicate in same room, same office, same building, so at that time we are using Ethernet technology in LAN. Okay, but
Mm-hmm.
when it comes to long coverage means, let's say different cities, we have two offices in different cities, and we have different offices in same cities, like distance is long. Okay, where the
Mm-hmm.
coverage is long. So when there is a long coverage, at that time we are using serial technology, because serial technology was slow, but it gives us a long coverage. Okay.
ADSL is a serial technology.
Yeah,
ADSL.
ADSL comes under serial technology. Yes, ADSL, and what you call, we have a serial link called DTE, DCE, like this. And if you are talking about ADSL router, which we are using in our home, that comes under Ethernet technology, because in ADSL we are using fiber, like a thin fiber we are using.
Mm-hmm.
All right. So, but what happened as the day passes? So Ethernet technology become advanced. Like earlier, it was only Ethernet, which which gives us only 10 Mbps of speed. Then it comes to fast Ethernet, which gives us 100 Mbps of speed. Then gigabit Ethernet, 10 gigabit Ethernet, 40 gigabit Ethernet, 60 gigabit of Ethernet. Okay.
Mm.
So the one drastic change is fiber optic cable is comes under Ethernet technology. Just give me a minute. So fiber optic cable comes in in Ethernet technology, which gives us a huge speed like 40 GB per second. Plus, it provides the long distance also.
Okay.
So it means Ethernet technology is fast, as well as it gives us a long distance coverage. So why should we use serial technology, which is slow, right?
Yeah.
So that is why in current situation, no one is using serial technology. Very less people are using it. So everyone is using Ethernet technology. Okay. This is the symbol of serial technology. It will be linked like this. Serial technology. All right.
Mm-hmm.
And Ethernet technology like this. Only the single line. All right.
Okay.
Okay.
Sorry. What's with the single line and double line? There should be only.
No, no. Single line it is an indication Ethernet technology. That's it and nothing else.
Okay.
Let's say you want to show me that two offices are connected on serial link. So like this is how you are going to show me, like this. So this is a symbol of serial technology. Now if you want to show me that my two offices are connected with the Ethernet, so like this is how you can show, like this.
Mm.
Got it?
Yeah.
So this is the symbol of Ethernet technology and this is the symbol of serial technology. Everyone is using this now because it is fast, plus it gives us a long distance also. All right. So can I change the slide?
Yeah.
All right. So till here you are understanding everything.
Yeah. All good, man.
All right. If you have any doubt, you can ask me. All right. So in Ethernet technology, in our class we have to learn about the two types of wire, which is called the twisted and fiber optic cable. Okay.
Mm.
So these two types of wire the CCNA exam wants us to learn. So twisted pair cable there is giving is supporting. Always understand that wire does not give you a speed. Wire only support the speed. Okay. So
Yeah.
the twisted pair cable is support speed up to 10 Mbps, 100 Mbps. Maximum it can support 1000 MB per second. Okay, and it gives us a coverage of 100 meters, and we can use it on hub, switch, and router. We can use it on all the three devices. All right.
Yeah.
Now, when it comes to fiber optic cable gives us a 40 Gbps of speed and 40 Gbps of speed, and it is only used on switch and router. Okay.
Okay.
So let's understand in a very deep manner how it works and all. So let's see here. See here. Okay, twisted pair. So twisted pair wire is looking like this. We are using the LAN cable in our home, right?
Yeah.
The LAN cable is called the twisted pair. So if you cut the twisted pair, so inside the twisted pair there are 8 wires. Okay.
Yeah.
So inside the twisted pair there are 8 wires which
Mm-hmm.
is basically coupled with each other in the pairs of two. See the two
Yeah.
wires are tightly coupled. Two wires are tightly coupled. Two wires are tightly coupled here. Okay.
Mm-hmm.
So it is in the pair of two. So totally there are 8 wires. Two, 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 and two. All right.
Yeah.
So when you cut the twisted pair cable, total there are 8 wires which is tightly coupled with each other. Okay. So there
Yeah.
are four. So if you talk about the twisted pair cable, it gives us a speed of maximum. It support is speed up to 1000 Mbps, and the connector which is used in uh, twisted pair is called RJ45. Have you ever seen RJ45 connector?
Yeah. Yeah.
Yeah, and it is of 8-pin connector, right?
Yeah.
And it provides the coverage of 100 meters. This wire gives us coverage of 100 meters. We can stretch the network up to 100 meters. We can extend more also, but the network signal getting drop after that. Okay. So
Mm.
100 meter is the maximum limit for this twisted pair. In a multiple types of pairs are there, which are providing more speed as well. So in twisted pair, we have two types of twisted pair. We have shielded twisted pair and we have unshielded twisted pair. Now,
Mm-hmm.
what are the difference between shielded twisted pair and unshielded twisted pair? And when to use shielded twisted pair and when not to use and when to use unshielded twisted pair, right?
Yeah.
So the first difference is the shielded twisted pair is having a shield of metal shield is having over it. Okay. The metal shield is over it, on shielded. In unshielded twisted pair, we don't have any metal shield. Okay,
Yeah.
that is why name called shielded. Shield means we are having a shield over it. Metal shield it is.
Yeah.
Unshielded means we don't have any shield over it. The wires it is like this only. Okay, so this is the first difference. Now why there is a shield and why there is no shield? What is the purpose of this, right?
I think, yeah, to stop the electromagnetic interference from outside.
Yeah, that's good. Now you are a student of telecommunication, right? Telecom student, you are right?
Yeah.
Yeah, that's good. So we are like a metal shield to protect the signal from radiation, right?
Yeah.
Because the radiation is the enemy of our data, and when the signal is passing from the wire, so this radiation try to stop the communication, try to interrupt the communication. So to protect from radiation, we are using shielded twisted pair. Now, when do you shielded twisted pair? In outdoor cabling. Whenever you are doing outdoor cabling, like let's say you are giving wire from one building to another building, so that
Yeah.
wire must be your shielded twisted pair. Okay, because it's
Yeah.
going to protect it from the radiation. See, have you ever noticed that any wire which is coming from outside to our home is is a very hard. Like when you touch and when you press it, it is very hard, right? Because there is a metal shield inside the wire. That metal shield is protecting your data which is from outside to your home, right?
Yeah.
All right. So when to use unshielded then? When to use unshielded twisted then? In indoor cabling. In indoor cabling, because in indoor cabling we don't have much radiation, right? So in indoor cabling we don't have a problem of lightning strike. We don't have a problem of radiation. So in indoor cabling in our home, in our office, we are using unshielded twisted pair. But in outdoor cabling we are using shielded twisted pair. Got it?
Yeah. Cat 5 is unshielded, isn't it?
No, the in Cat 5, Cat 6 or Cat 4 there are two categories, shielded and unshielded. In every
Ah,
category there is shielded and unshielded.
unshielded.
Whether it is Cat 5, Cat 6, Cat 4, anything. So in every category, we have two types of wire, shielded and unshielded. Okay.
All good. Yeah.
Okay. So can I change the slide now?
Yeah.
All right. See here. So so there are multiple types of wire called Cat 4, Cat 5, Cat 6. Now what is the difference? First difference is thickness, right? Which is physically access. See, Cat 4 is thin, Cat 5 is more thick than Cat 4, and Cat 6 is more thick than Cat 5, right?
Yeah.
So the physical difference is the thickness, but the thickness is not an important factor. The important factor is number of atoms, right? So the wire
You
which is
mean the
more
wire gauge is thick? Like each individual wire gauge is thick?
age, no, the wire is thick. See, the wire is thick, not the age. The wire is thick.
Okay.
All right. The wire is thick plus it is also thick in this. Here it is also thick and here it is also thick.
The plastic cover is
Yeah.
also thicker
Yeah.
than.
Also thick. Everything is thicker than. Let's say we have talked about the Cat 5. So Cat 5 and Cat 6. So Cat 6 is more thicker than Cat 5 in compared to anything. In compared to copper, in compared to plastic, in compared to cover. In each and everything, Cat 6 is more thicker than Cat 5. Got it?
Yes.
So the wire which is more thick is able to support more speed because of number of atoms. The wire which is more thick contain the more number of atoms, and the wire which contain the more number of atoms can support a higher speed. All right.
Yeah.
Okay. So can I change the slide?
Yes.
All right. Yes. This is called RJ45 connector, right?
Pin 8. Yeah.
This is the RJ45 connector. All right.
Yeah.
This is, yeah. Now RJ45 connector is contain of 8 pins, right?
Mm-hmm.
But in 8 pin, only 4 pins are usable. That is pin number 1, pin number 2, pin number 3, and pin number 6. Okay.
I thought only 2 pins were used to send the signal.
Now only
Then.
only 4 pins are usable. I will show you. Only 4 pins are usable. 1, 2, 3, and 6. In the cable there is only 4 wires. That only 2 cables are used. Okay. Then if you are talking about the 8 pairs, so pin number 1, 2, 3, and 6 are usable to send data and receive the data.
Uh-huh.
Okay. But what about this? The remaining pins 4, 5, 7, 8. It is used for PoE, power over Ethernet.
Ethernet. Okay.
Yeah, have you ever heard about the power over Ethernet?
Yeah. I have heard that smart features you can control the lights and everything.
No, power
Um.
over, yeah, you are right. Power over Ethernet is a device whom you are not supposed to give power. Let me show you. You have seen this type of this access point which is there in our offices. Okay, Cisco AP. See this one.
Ah. Yeah.
Yeah, this right.
Mm.
So this is the Cisco access point. This is the Cisco access point. Okay. You only connect the LAN cable to it. That's it. No need of giving power and all. So from the same wire, it send and receive the data. From the same wire, it receive the electrical signal also. Okay. See, like the back
Mm.
panel, like this it is. Okay. So with the help of same wire, we connect the access point and no need of giving power. Just stick on the wall and just connect the LAN cable to it and it is getting power from the same wire plus, plus it gives you speed also. Alright?
Yeah.
Okay. So in the same way we have an camera also. See we have a CCTV camera whom we don't need to provide access power, right? Just we are just connecting the LAN cable to it.
Yeah.
And from the same cable it receives the electrical signal also and its same signal electricity also see here this see it is written that PoE plus, right?
Yeah.
So the switch is also supporting the PoE. There is a little bit difference between PoE and PoE plus. PoE plus is giving more power than PoE. All right.
Yeah.
Okay. Now, so I'm talking about this. So this is your RJ45 connector. It contains of 8 pins in which only 4 pins are usable. Pin number 1, 2, 3, and 6. The remaining 4 pins is used for power over Ethernet. Alright.
All right.
Power over Ethernet is a new technology in which we don't need to provide a power to device. Only we need to is to connect the LAN cable to it. Okay. And from the LAN cable it receives the send and receive the data from pin number 1, 2, 3, and 6. And from the same cable it also provide the power. Okay.
Okay. Yeah.
All right. See here, this is the deployment of power over Ethernet. See here. See here.
Mm.
We are having a desk and we have a CCTV, we have an IP phone, we have our access point, and this is the switch. See, no additional power is given. There is no adapter, right? There is no power adapter for this. We only connect the LAN cable from the switch, and switch will provide the power to the
Yeah.
this device. Got it?
Yeah.
So this is how the PoE is developed. Like we develop the network for PoE. Okay, setup. Got it?
Got it.
Okay. So can I change the slide?
Yes.
All right. Now twisted pair wire. In twisted pair wire, we are having a two types of wire. Let me show you. So this thing. In twisted pair cable, we can make two types of cable: straight cable and cross cable. Okay. What happen in a straight cable? In a straight cable, color coding must be same on both the sides. As I said that in twisted pair, only four pins are usable. One, two, three. Right. So let's say on A side. Hello, are you listening?
Yeah, I'm listening.
So let's say side, on A side, on pin number one, I'm connecting orange cable. So on B side also, there must be a orange cable on pin number one. Okay.
Yeah.
On A side, if you connect green cable on pin number two, so there must be a green cable on pin number two on the next side also. So it
Straight
means
cable used for same devices, isn't it?
straight cable is used for different device.
Different device.
Different device, like from switch to PC, switch to router.
Okay. I thought
Okay.
this was gone now. All the
Yeah,
cables are same.
all the cables are same. I'm coming to that point also. Now there is no straight cable and no cross cable because there is one technology is coming in the market called MDIX.
Uh-huh.
MDIX is the new technology which is auto detecting. Okay,
Okay.
which is auto detecting. So nowadays there is no straight cable and there is no cross cable. But that then also I'm explaining you this thing because if someone asks you, then you must have an answer for this. Okay. So in a straight cable, we are using a same color coding on both the sides. In cross cable, we are using different color coding on both the sides. Okay.
Okay.
Now, what is that color coding? See, this is the color coding. This is color coding. Okay. See this. So there are two types of color coding: orange, it is green, white, blue, blue, white, green, and brown, white, brown. Okay.
Yeah.
And there is another color coding called green, white, green, orange, white, blue, blue, white, orange, and brown, white, brown. Okay.
Okay.
So we have two types of color coding. So if we want to make an straight cable, if we want to make a straight cable, then we can use one color coding, and that color coding should be same on both the sides.
Mhm.
Okay. Let's say if I pick orange, white, orange color coding on A side, so I have to select the same color coding on B side. Okay. But
Yeah.
if you want to connect, if you want to make cross cable, if you want to make cross cable, then in cross cable we must have a different color coding. Let's say on A side, if we have an orange, white, orange, so on B side we must have a green, white, green.
Yeah. Um.
So in straight cable color coding is same. In cross cable color coding is different. All right.
Yeah.
Okay. So can I change the slide?
Yeah.
All right. See. So in twisted pair, there are two types of cable called shielded twisted pair and unshielded twisted pair. In shielded twisted pair, we have two types of cable: Cat 4, Cat 5, Cat 6. In unshielded, we have also Cat 4, Cat 5, Cat 6. I have tell you right
Yeah.
that in both the types we have shielded and unshielded. Okay, then we have straight cable and cross cable. Straight cable are used in a different device and cross cable are used on a same device. PC to PC, switch to switch, router to router. But nowadays, a technology is come into the market called MDIX. MDIX. With the help of this technology, the device are using auto sense feature. You can connect any cable, they auto sense from which wire to receive.
Mm.
Got it?
Yeah.
So can I change the slide?
Yeah.
All right. See, when to use straight and when to use cross. So this is not applicable nowadays. But in interview, sometimes they ask the color coding. Sometimes they ask when to use straight cable and when to use cross cable. So that is why. Okay.
Okay.
So you must have an answer like when to use and why to use. So cross cable is for same device and straight cable is for different device. And we have to if you want to make straight cable and cross cable, then this thing must be there with you. A testing cable, uh, a crimping tool,
Print.
RJ45 connector, and a cable. Right?
Mm, yeah.
Have you ever done the crimping?
Yes. Long time back.
Yes. Yes. So after crimping, we are just checking all the 8 pins are working or not. Right?
Yeah.
See, this is how we cut the cable. This is the 8 pairs, right? Orange,
Mm.
white, orange, green, white, blue, blue, white, green, and brown, white, brown. This is the color coding. Okay, so that's all about the twisted wire. Now let's move on the next topic called fiber optic cable. Now in fiber optic cable, it provides speed support speed up to 40 Gbps to 60 Gbps and more than that. And in fiber optic cable, we don't have one type of connector. We have multiple types of connector. We have SC, SC, LC, and we have multiple types of connector in fiber optic cable, right?
Okay.
Depend upon our need, we are using that type of cable. Okay. So one major difference is in fiber optic cable, we have two types of cable. We have two types of cable, single mode and multi mode. Single mode and multi mode. Okay. Now, by looking at the cable single mode and multi mode, you cannot identify whether it is single mode or multi mode. Okay, because
Yeah.
they look similar. They look similar. So how can it make the difference of single mode and multi mode? Diameter. You can see the diameter. Hello.
Yeah. Yeah.
Yes. Yeah. The single mode diameter is as compared to the diameter of multi mode. See here. Okay.
Yeah.
So because of this diameter difference, okay, what happened in the fiber optic cable? The laser light is going. Okay, the laser light is passing as a data. Okay,
Yeah.
the laser light is passing the data. So in fiber optic cable, we have two types of cable called single mode fiber optic cable and multi mode fiber optic cable. In single mode fiber optic cable, there is no chance of reflecting the light. See, the light will come and smoothly go because there is no space, there is no place to reflect, right?
Yeah.
As compared to multi-mode, in multi-mode, we are having a huge space inside the wire, so there is a chance that light cannot go straight and it can reflect. So that is why we are using multi-mode cable in short distance and single mode cable in long distance. Got it?
So single mode is long distance, isn't it?
Yes, because in single mode there is no room for reflecting the light. Okay.
Yeah.
Now, see, these are the fiber module. These are the fiber module which is used in switches. Okay, and we connect the cable here. It is not like an our twisted pair. Twisted pair is only one cable which is connecting in a one link, right? And
Yeah.
from the same wire, data is sending also and data is receiving also.
Yeah.
But in fiber optic cable, we cannot directly connect it into a switch. See, if I show you the picture, see here, here, this is the port. This is the port where we connect the fiber module.
Okay.
Wait, I'll show you how to connect this. This is the port where we connect the fiber module. Let's say this is a switch, okay, and we have another switch also. We have another switch here, and I want to connect switch to switch. So what will do? I will connect a fiber module here. Okay.
You mean router switch?
Yeah, no. If you want to connect router to switch also, then also you can use fiber optic cable. And if you want to connect switch to switch also, then also you can connect it. So
Okay.
let's say
But
I
you
have a
cannot use the Ethernet ports. That's what you're saying.
no Ethernet port we cannot use. For fiber we have additional port. This is called uplinking port. Uplinking port is that port which are using to uplink. It is used to connect to our switch, and it is a GBPS port. It minimum it is having a 10 Gbps or 5 Gbps of speed. It is Gbps port. Okay.
Yeah.
So what we'll do, we connect a fiber module. Okay, and in fiber module, as I show you, there are two slots. See, there are two slots, right?
Mm.
So one cable is for sending. Here also we have a fiber module. This is also a switch. So here we also are having a fiber module. So one for receiving and other one is for sending. So two cables are connecting in fiber optic cable. One for sending and another one is for receiving. Got it?
Yes.
So this is how the fiber optic cable is. No. What happened then? So let's say we have a computer over here, right?
Mm-hmm.
And we have another user which is sitting over here.
Yeah.
Now let's say this guy wants to communicate with this person. So it sends the data. So when data goes here, it is in electrical energy form, and when this data came here, it converts the electrical data into laser light.
Mm.
Okay, this fiber module, this fiber module, when it receives the electrical signal, so it converts the electrical signal into an laser light. Okay,
Okay. Yeah. Mm.
it converts that electrical signal into laser light and pass the laser light very fast from this wire, and this fiber module will receive the laser light. Okay,
Okay.
and
Yeah.
when it receives the laser light, it converts the laser light into electrical signal, and after converting into an electrical signal which is binary zeros and ones, it sends it to this PC, and this will receive the frame. Got
Mm.
it?
Yeah.
So it means fiber optic cable is used when connecting to switch, when connecting switch to router, and in fiber optic cable we are using two wires, one for sending and one for receiving, right? And fiber optic cable is not directly connecting into this port. If you want to connecting into this port, then it is not possible, because in fiber optic cable we are having a two cables and this is for one port, right?
Mm.
We have two ports, so that is why we are using fiber module. one for sending and one for receiving. If I show you, see it is clearly mentioned. See this arrow. This arrow means the incoming port cable, and this arrow means the outgoing cable, right?
Yeah.
The arrow sign is there. Okay.
Yeah.
So in fiber optic cable, we are using the fiber module. So there are two types of fiber module: SFP and GBIC. Got it? This one is SFP, which is a small, and GBIC is depend upon the need of the company. They are using, most probably this one is using SFP.
Okay.
Okay.
Hmm.
See, this is how it connects. See here. See, I've shown you, right?
Hmm.
So this is the switch. So first we connect the fiber module. So that is why the port is also 20. There is a difference. See, this port is different and this port is different. Right. And see, it is written also SFP. See, SFP. Can you see this?
Yeah.
SFP. So it means we have to connect SFP fiber module over here.
So you cannot use the other one.
Now it depends
GB.
upon the, yeah, it depends upon the type of switch. If we have a big switches which allows us to connect GBIC, so in that case we will use the GBIC depending upon the switch model. So most probably we are using SFP.
Okay.
All right.
Yeah.
And this is
So
how we
it
connect.
doesn't important. There is no like a technical difference. Like one is like high speed, other one is slow speed.
Yeah, there is a technical. I have shown you why there is a see. If you see the multi-mode and if you see the single mode, you cannot identify. You cannot identify between the single mode and between the multi-mode because they they both look same. The difference is, the technical difference is of diameter, right? I've shown
Yeah.
you the diameter. I've shown you the diameter. See, this
Yeah.
is the
Yeah. I
diameter,
see the
right?
diameter. Yeah.
So this is the technical difference, right?
Mm-hmm.
Okay, this is the technical difference. They both are having a diameter. So the single mode diameter is very small as compared to multi mode, and due to this technical difference, there is a possibility of reflecting the light in multi mode, and there is no possibility of reflecting the light in single mode. So it means
Yeah.
the single mode cable can cover the more coverage as compared to multi mode. So that is
Mm-hmm.
why we are using multi mode in short distance and we are using single mode in long distance.
That's true. No,
Mhm.
I mean the connectors.
No, the connector is same for both, for single mode
It's
as well as for multi mode. Yeah,
okay. Yeah. Okay.
because the width and the thin is same for both the wire, right? So both the wires are using the same type of connector.
No, what
See
I
here.
am asking is like
Mhm.
so it's just like two. You can use either one, but there is no any technical difference with
No,
those two connectors.
yeah, there is no technical difference. The technical difference is only this: they are having a big diameter, okay, and you can use multi-mode in short coverage.
Short. Okay.
Yeah, okay, you can use the multi-mode in short coverage, and you can use the single mode in long coverage.
Okay.
All right,
All right.
okay. Simultaneously, you can write it down also something because
Yeah,
as
I'm
you are
writing
not
down.
taking the screen, yeah, yeah, as you are not taking the screenshots, when you will get recording, you can view the content and you can view everything. But for right now, you can just write it down, no, simultaneously. Okay.
Mm.
All right. So this is how we connect the fiber optic cable. Okay.
Yeah.
See, this thing. Let's say we have 60 user here, we have 60 user here, and we are having two switch. So we are using fiber optic cable and fiber module between the switches, right?
Yeah.
Between the switches, we are having this thing, and it converts the fiber module convert into laser light like this. Okay. From here it passes the electrical signal, but the fiber module converts it, right?
Yeah.
So can I change the slide?
Yeah.
All right. Okay. So the next topic is CSMACD. Now what is this CSMACD? You have learned this thing in your engineering, right? In engineering we have a CSMACD.
It's a
Career,
multiplexing method, isn't it?
career sense multiple access collision detection mechanism, right? So
Mm.
let me explain you. Let me explain you. So CSMACD. Basically CSMACD is a software of Ethernet technology. Ethernet is a technology, okay, and technology is having a two parts, hardware and software. Okay,
Yeah.
hardware means all the physical components like cables, wires, connectors, all the physical components which is there in a technology. Okay, so that physical thing is called the hardware, right?
Yeah.
And to create understanding in hardware, like how to work, like my laptop is a hardware, but the operating system in laptop is a software, right?
Mm-hmm.
And that software is guiding my laptop, that software is guiding my hardware how to operate, right?
Yeah.
In the same way, in technology also we are having a hardware and we are having a software.
Mm-hmm.
So Ethernet technology is having a software called CSMACD. Okay,
Okay.
so this CSMACD, this CSMACD, all right, it this CSMACD is a software of Ethernet technology which
Mm-hmm.
create understanding in the hardware of Ethernet technology how to operate. Okay,
Mm-hmm.
but before learning the CSMACD, first understand what is full duplex and what is half duplex. Half duplex means one way communication. Only I can speak, and when I'm speaking, no one else can speak in between. Right?
Yeah.
This is called the half duplex. Only one person can talk at a time, and everyone will be in a
Like
listening mode.
broadcasting.
No, broadcasting is another thing. Yeah, you can say broadcasting. In broadcasting, one person is sending the broadcast, and everyone is receiving the broadcast. Right?
Yeah.
Yes. Full duplex means two-way communication.
Yeah.
Two-way communication means at the same time I am also speaking and at the same time you are also speaking. This is called the two-way communication. So this is
Yeah.
called the full duplex, right?
Mm.
So what we are doing, we are learning the CSMACD from
Mm-hmm.
half duplex point of view, from hub point of view. Hub was a half duplex device. Right now, no one is using a hub. So why we are learning this? Because in our syllabus, let me show you the syllabus. So in our syllabus point of view, what we have learned till now, we have learned router and we have learned switches. But in more deep way also, I'm going to you. Don't worry about this. So we have learned this thing right now. We have completed this single mode, multi mode, copper, right?
Yeah.
Connection, Ethernet, shared media, point to point. And right now we are here. We are doing this thing. Collision. So to make you understand this collision, error, mismatch, so I have to explain CSMACD. Got it?
Yeah.
So hub is a half duplex device, switch is a full duplex device. So to make you understand what is the collision, what is error detection, so I have to use this hub device. Okay.
Mm.
So what we are going to learn right now? Right now we are going to learn CSMACD. Okay. And we are going to learn CSMACD from hub point of view. which is half duplex. Okay, it means only one person can talk at a time. All right.
Yeah.
So now let's start the CSMACD. So so now let's understand what CSMACD is trying to say. CSMACD says that two or more computers, two or more computers or communicating device, okay, can communicate with each other whenever they want. But but if if any computer wants to communicate with any other computer, then this computer have to sense whether medium is idle or not. Okay,
Uh-huh.
if medium is idle, if medium is blank, no one is using the medium, then only this PC can acquire the medium, right? Then
Yeah.
only it can acquire the medium, and when it acquires the medium, then only it will send the data. But what happens when this computer sends the data will go to every computer on the segment.
Mm.
But only that computer will reply to whom data was sent, because at the time of sending the data, this computer add the source code and destination code, right? Source code and destination code, that's from A. This frame is for from A and it is going for D. So when B is receiving this frame, so B will say that, hey, I am not a D. So B will reject this. C will receive the frame and C will also say, hey, I am not a D. C will also reject this. But
So
D
are we
will
using the
accept.
MAC addresses?
Yeah, they are using the MAC addresses. The computer are seeing the MAC address. The hub is not understanding the MAC address and all. This source code and destination codes are MAC addresses. Very good. So the computer is an intelligent device. They are detecting the MAC address. Got
Okay.
it? And I'm also going to teach you MAC address in a very deep manner. Okay. So till here everything is very good. Okay.
Yeah.
But the problem comes when two devices are communicate at the same time, right?
Yeah. Yeah.
When two devices communicate at the same time, then the problem arises. Now let's say at the same time A and D both send the data to each other, and it is a half duplex, right? Hub is a half duplex device. So what happens if two computers send the data at the same time? So what happens? This data will come here and this data will come here and they get collide with each other. Okay, the data get collide with each other in half duplex if two device send the data at same time, so the data get collide, all right, and the collision occur, and the collision occur. Now what is the meaning of collision? When two moving objects collide with each other is called collision, right?
Yeah. I thought the second communication, when another computer want to communicate, they wait until the first one stop communicating.
Sorry, hello.
Now the first computer is communicating, and the second one also want to communicate, and
Yes.
I, I, yeah, the second one has
Yeah,
to wait, right?
yeah, has to wait. But I'm talking about, see, I'm talking about when both the computers, see, right now assume that right now no one is using the medium, right?
Yeah,
Right now no one is using the medium. So I also send the data and you are also send the data, right?
yeah,
So my computer will detect whether medium is idle or not. Your computer will also detect whether medium is idle or not, right?
mm,
So right now no one is acquiring the medium, right?
okay,
No one is acquiring the medium right now. Just
yeah,
assume that. Just assuming that. Right
So you
now,
are telling both of them got the same time?
yeah, that's what I'm trying to do. At the same time, if both the device send the data, so that data get collide like this.
Uh-huh.
Okay. So when at the same time both the device send the data, so that data get collide and collision occurs.
Mm-hmm.
Now you got my point?
Yeah.
Okay. So now what happens if this collision occur? The frame and the data get collide. That data get corrupted, right?
Yeah.
And that data get corrupted. Then how my computer will get to know? Because whenever the collision occur, so this is the hub. So what hub will do? Hub will resend the frame back to the computers like this.
Uh-huh.
So how come my computer will detect whether it receive a collide frame or non-collide frame, right? So here comes the collision detection. Here comes the collision detection. So
Okay.
CSMACD says, hey, don't worry. I have a mechanism called collision detection. Okay. So whenever you receive a frame, you just check the CRC code, right? Let's say this is the frame and this is the data, okay? And this is the CRC code. CRC code is cyclic redundancy check. It is a parity bits, right? Have you ever
Yeah.
heard about the CRC code?
Mm-hmm. Yeah.
Yes. So CRC code is a parity bit. It shows that what is there in the data. Okay. So what
It's in the
happens?
data line, isn't it?
Yes, yes. So what happens when this computer receives the frame? The outcome is when this computer receives the frame back after collision. So it will check the CRC code and then it will match with the data. If it gets matched, then my computer detects that it is not a collide frame, it is a normal frame. And when it detects, because see, when the collision is occur, there is a sequence change in the CRC code or there is a sequence change in the data. Okay,
Mm.
because when two cars are collide with each other, their sequence
Yeah, the
will
one
change.
and zeros are going to change.
Yeah, the bits are going to change. Okay, let's say before the bits are like this: 111, 000, 111, 000. After collision, it changed to 010101. So the
Yeah.
sequence is changed now, right?
Mm.
So the CRC code is not matched with the sequence.
Yeah.
So my computer will detect that it receives a collide frame. And this is
Yeah.
how, with the help of CRC code, my computer will detect that it receives a collide frame.
Collide frame. Yeah.
And when my computer realizes that it receives the collide frame, so for particular seconds, it goes in integral wait state. Integral wait state is that wait state in which computer can only receive the data. It is not able to send the data.
Okay.
Okay. So let's say you are the device. You are the device. Okay. You are the device and you receive the collide frame. Okay. You
Yeah.
receive the collide frame. So when you realize that you receive the collide frame, so what you will do, you will punish yourself. Just give me a minute. Then just give me a minute. So means as your computer, so you receive a collide frame and you realize that oh I receive a collide frame. So what you will do? You will punish yourself and you will go in integral wait state for some second. Let's say for 1 second. Okay. But why? But what is integral wait state? Integral wait state is that wait state in which you are only receive the data, you will not send the data for some seconds, right? But why I will go in integral wait state? Because why collision occur? Because communicating pairs are more. So in this, if I also go for communicate, if I also go to send the data, then there might be a chance to increase the collision, right?
Yeah.
So that is why as a computer, as a device, I will go in integral wait state for some seconds. So it means if all the computers receive the collide frame, so for a second, the whole network is stopped. So
Yeah. So
the
just to
drawback of
clear,
collision.
like
Yes.
one
Mhm.
computer will receive all the packets from other send as well, isn't it? Like collision packets and all the data, and computer will check the CRC code and check for the collision. Now other packets also detecting as collision packets, isn't it?
Yes, because this is a hub. So what happen in
Yeah.
hub? What happen in hub? Everything goes to each and every computer,
Yeah.
whether it is for you or whether it is not for you.
Yeah.
Okay, everything is go for everything, everyone. Like everyone will receive each and everything, and the computer will decide whether the frame is come for computer or not.
Yeah. So that will be
Because
checked by using CRC, isn't it?
yes, by using CRC code. So as a computer, when you receive the frame, normally or collide frame, you always check the CRC code and you match the CRC code with the data.
Okay.
And if it is match, then you came to know that okay, the integrity is good, the data, the integrity is good, the data is good, and you will receive the data, you will accept the data. But if the CRC code and data is not matched, their parity bits is not matched, then you came to know that okay, I receive a collide frame, right? I receive a collide frame. And when you realize that you receive a collide frame, so you punish yourself, you go in integral wait state for particular 1 second or 2 seconds to avoid the
And try
more
it again.
collision. So yeah, to
Okay.
avoid more collision.
Gosh. Another
Okay.
one thing, like this the receiver knows the CRC code.
Mhm. The CRC code is added by the sender PC.
Send a PC.
Yeah, let's say I am sending a file to you. So my
Hmm.
computer will add the CRC code,
Into the packet.
yeah, into the packet,
Okay.
which is called cyclic redundancy check, which is called FCS, frame check sequence. Got it?
Yeah. So I'm a little bit foggy on these data frames. Um, so the CRC check was a parity bit, isn't it?
Yeah,
Basically.
it is a parity bit. It shows
Yeah.
what is there in the data. What is
Yeah.
the sequence of the data?
What is the sequence of this? Yeah.
Yeah,
So
what is
my
yes.
my question was like, just say computer A sending to computer B,
Mhm.
and how does the computer B knows this packet coming to you?
Yeah, because of the Mac, because
Ah,
of the
this in
Mac.
the Mac. Ah, okay,
Yeah,
okay, okay, okay.
this
Yeah,
is
I got it.
this is in the Mac. So from here it came to know that oh, this packet is for me, and
Me.
after realizing that this packet is for me, it will accept the frame. And later on, I'm going to show you each and everything. Don't worry. Today only, I will show you how communication take place in the network hands-on experience. My hands-on experience as a network engineer. Right. Okay. All right. So now let's continue. So this is called your CSMACD, in which two computers can communicate, but only one person can communicate at a time. If two computers communicate at the same time, then their data get collide. And how they detect whether data get collide or not, with the help of CRC code. So
Yeah,
whenever any computer receives a frame, it check the CRC code, all right. And if the CRC code and data is matched, then the frame is okay. And if CRC code and data is not matched, Then computer detects that it receives a collide frame. And as soon as computer detects that it receives a collision frame, it receives a collide frame, it goes under integral wait state for some for some seconds to punish himself or to avoid the collision. All right, not to
Oh,
punish
yeah.
himself, to avoid the collision. All right. So this is what your collision CSMCD. Okay. So this is the CSMCD. Okay. So while watching the video, you can pause the video and you can learn this. Okay. You can read this. All right.
Yeah.
Now the next topic is MAC address. Now what is this MAC address? Okay. So let's say you are in an interview, and as a interviewer, I am asking you, hey Dennis, what is MAC address? Now, how you are going to explain what is MAC address?
It's a unique number assigned to each device
Mm-hmm.
um, for identification purposes.
Mm-hmm. That's it.
Yeah.
See, to having a knowledge is a good thing, and how you express your knowledge in your interview is another thing. Okay, so I'm giving you wordings. So MAC address is of 6 octet, 6 byte, 48 bit hexadecimal address in which 0 to 9 numbers and A to F alphabets are used. All right. Now
Yeah.
I'm going to explain you each and everything, and I'm going to prove each and everything. See, anything which is stored in our computer or mobile is having some size. So MAC address is having 6 fields: 1, 2, 3, 4, 5, 6. So MAC address is having 6 fields, right?
Mm-hmm.
And the size of one field is of 8 bit. One field size is of 8 bit. So
Yeah.
if the size of one field is 8 bit, if the size of one field is 8 bit, then what will be the size of all bits? It is total of 48 bits. So
Okay.
the size of the total size of the MAC address is of 48 bits. And how come it is possible? The size of one bit is 8 bit, and there are total 6 fields in MAC address. So that is why the total size of MAC address is of 48 bit. So
Okay.
one point is clear to you.
Yeah.
Now, if you join 8 bits, it becomes 1 byte. 8 bit is equal to 1 byte. Okay.
Yeah.
So if one field is of 1 byte, then 6 field is of 6 byte.
Yeah.
So I prove second point also. Now the group of 8 is called octet. The group of 8 is called octet. Like 8 zebra group is one octet. 8 chairs group is one octet. 8 bottles group is one octet. The group of 8, anything which is in a group of 8 is called octet, right?
Mm-hmm.
So here also the group of 8 is there. 8, 8, 8, 8, 8. Like, so one field is said that one octet. So if one field is of one octet, then six field is of six octet, right?
Mm-hmm.
And plus here everything numbers and everything are same. Like 0 to 9 numbers are using, and A to F alphabets are using. So any place where 0 to 9 numbers and A to F alphabets are used, so that is called an hexadecimal address.
Yeah.
Okay. Now MAC address has multiple names. MAC address is also called as physical address, hardware address, layer 2 address, machine address, burn-in address. So like MAC address is having multiple names. Alright.
Yeah.
So now you know what is MAC address.
Yeah.
So MAC address is of 6 octet, 6 byte, 48-bit hexadecimal address in which 0 to 9 numbers and A to F alphabets are used. MAC address is also called as physical address, hardware address, layer 2 address, and burn-in address. Alright.
Okay.
So now you have a proper definition of MAC address. Okay.
Yeah.
Now, so can I switch the slide?
Yeah.
Alright. Now, another will go in more deep. Every computer or every device in this world has a unique MAC address. Okay. No
Yeah.
device in the world is having a same MAC address because it is managed by IEEE. Okay.
Yeah.
Alright. Now, what is ping? What is ping? There is some kind of noise is coming from your background, like yeah, like this. Yes. So next is ping. Next is ping packet internet gropper. So what is ping, Dennis?
Uh, Normally we used to check the connectivity
Mm-hmm.
and then the latency.
Okay.
Mm,
Have you ever pinged a device?
yeah. Yeah.
Yeah. So basically, ping is a tool. Ping is a tool, or you can say it is an application of IP. Okay. Right now we are working on TCP/IP.
Yeah.
Okay, the TCP/IP is the protocol on which currently we are working. We are talking with TCP with the help of TCP/IP. So
Mm-hmm.
IP is an upper layer protocol stack. What do you mean by upper layer protocol stack? Upper layer protocol stack is a stack in which there is multiple software tools and applications are there. Okay. So IP is an upper layer protocol stack which contains thousands and hundreds and thousands of applications and tools. Okay. So ping is one of a tool of IP which is used to get network layer status of connected device. Let's say, for an example, let's say, see here, if you see this is my computer which is having IP of 10.0.0.1, and this is your computer which is having an IP of 10.0.0.2, right? Now let's say I want to share some file with you, or we want to play a game on LAN. So first of all, I have to check the connectivity, right?
Yeah.
Whether our computers are connected with each other or not. So what I will do, I will ask that, hey Dennis, what is the IP address of your computer? So you will give command IP config, and you will take the IP address and you will tell me that, hey Sohail, I have an IP address of 10.0.0.2, right?
Yeah.
So what I will do, I will go to my command prompt which is CMD, and I will
Mm-hmm.
type in 10.0.0.2. Okay. So
Yeah.
after giving this command, immediately reply are coming, right? So let me show
Yeah.
you how to ping. See, if I ping my gateway, ping 192.168.0.1, see the reply is coming,
Yeah.
right? So very fast reply are coming, right? So now what's happened when you do the ping to any device or any computer? So what happens is your computer sends the ICMP echo packet, Internet Control Message Protocol echo packet. Okay. See, these are the packets. See, packets stand for receive for loss zero. Okay.
Yeah.
So whenever we do the ping, so our device sends the ICMP echo packet. Okay. And this ICMP echo packet goes with the help of wire. it goes to connected device and check the network layer status of this device and again back to my computer. So anything which is back again, it shows that the connected computers are connected with my computer, right?
Mm.
Second thing is delay. It's showing that delay also. See here, the timing. See the millisecond, minimum 2 millisecond, maximum 3 millisecond, right?
Yeah.
See here it is showing that delay. This is called the delay. Delay means the timing in how much time it back to my computer.
Mm.
And last one is drop. Drop shows the link quality. See here, here there is no drop, 0% loss.
Mm.
0% loss means my link quality is good. There is no drop. My link quality is good. Okay.
Yeah.
So in short, if we say that what is ping? So ping is a tool or application. Ping is a tool or application of IP which is used to get network layer status of connected device. Ping sends ICMP echo packet. Alright, ping works on ICMP. So ping sends ICMP echo packet to get the network layer status. It is also used for the following: to check the connectivity, to calculate latency, which is called delay, and to verify link quality, which is called drop. Got it?
Yeah.
So now you clearly understand what is ping and all.
Yeah.
All right. Now, whenever see our computer is already having a MAC address, right? So, but for communication on the network, we have to give IP address also, right?
Yeah.
So whenever we give the IP address to our computer, so my MAC address and my IP address is getting mapped.
Yeah.
And this mapping is stored at two places, ARP table and NIC table.
ARP table and NIC.
NIC table, yes. Network
Mm-hmm.
interface card table.
Okay.
Okay. So because whatever IP address we give to our computer, it becomes the name of our network card. So my computer network card will known by this IP address in the network.
Okay. That is
All right.
hard embedded or
No, there is not coded. See here, I will show you. When you go to CMD and you give command IP config. See, this is my Ethernet adapter and I am connected wirelessly. So this is my Wi-Fi adapter, and this is the IP address given to. This is what called NIC table. This is the
okay.
IP address of my Wi-Fi card. So this is the IP address given to my computer. Now my Wi-Fi card is known by this IP address. All right.
Okay. Yeah.
So whatever IP address you configure in your PC or your laptop, it becomes the name of your computer. Your computer will known by this IP address in the network. All right.
Mm.
The,
Yeah.
the second is ARP table. ARP table is that table in which mappings are saved. Let's say my computer is having a MAC address AA and it's having IP address of this. So it is mentioned that ARP table that my MAC address is AA and its IP address is 192.168.1.10 like this.
Yeah.
All right.
Mm.
Okay. So can I change the slide?
Yeah.
All right. Now here is the main point, and it is not in the syllabus, but then also I'm going to teach you this thing because it increase your knowledge. It increase your knowledge. It provides you visibility that how data flows in the network. Okay.
Mm-hmm.
So in this topology in IP flow topic, In IP flow topic, I am going to show you when you send the data or you ping in a same network, then how your data flows and how you get see. Like I have ping here, right? I have ping my gateway, right? And the reply is coming, right?
Mm.
So what happened in the background so that my computer is getting the reply? So this thing I am going to show you now in LAN. Okay. Later on in man and WAN also I will show you how the packet flows. All right.
Yeah.
Okay. So let's start. So in IP flow, what I'm going to teach you now. In IP flow, I'm going to teach you in local area network, in same room, same office, same building, in same network, when one device communicate with another device, then how it get the data and how it get the ping replies. Okay.
Yeah.
So let's say this is my computer and you are sitting here on the fourth desk.
Hmm.
My computer MAC address is AA and my IP address is 10001 and your computer MAC address is DD and your IP address is 10004, right?
Yeah.
Now I have shown you that my computer will develop an ARP table which is called as layer 2 table and routing table which is called what we call NIC table. NIC table is also called as layer 3 table. Okay.
Okay. So the routing table is in the router, or
Yeah, it is in the router. It is by mistake name is given. Basically, it is
okay.
NIC. It is NIC table, not routing table. Okay.
Okay.
Routing table comes under router. Now, now what happens? See now what happens. So I will ask you, hey Dennis, what is your IP address? So you told me that my IP address is 10004. So what I will do? I will go to CMD and I will type ping 10.0.0.4, right?
Yeah.
And immediately replies start coming like this, right?
Yeah.
But in background what happens? So I'm going to show you. So now in background what happens? So I am as a user, I typing 10004 and then press enter. So now my computer will do each and everything, not me. Okay. So now what happened? Now my computer will create a frame. When computer communicate with each other, they don't have a mouth like a human being. So they communicate in the form of frame or packet. Okay.
Hmm.
Like I'm writing a letter to you, you are writing a letter to me. In the same way, computers are talking to each other by creating a frame.
Yeah.
So frame is like a letter which I'm sending to you and you are
Okay.
sending to me. All right.
Mm.
So now what happened? Now what happened? So my computer will create a frame. My computer will create a frame in which first field will be data. Okay, in which it is written that hey, I am ICMP echo packet. I am ICMP echo packet and I want to know your network layer status. Okay.
Hmm.
The second thing will be source IP address. Source IP address means the IP address of my computer.
Yeah.
So from where my computer will get the source IP address? From NIC table. My computer will go to NIC table and
Hmm.
ask, hey NIC table, what is our IP address? So it will tell that, hey, our IP address is 10001
Okay. The NIC table is in
in
the
our
computer,
computer. In
in our
our
computer,
computer. This both the table are in our computer. I have
but
shown
the
you
IP
NIC
address
table.
is assigned by the router, isn't it?
No, IP address is assigned by DHCP server or we manually assign, which is called statically.
Statical. Okay.
Router does not assign IP address, but if you make router as a DHCP server, then your router will give you IP address. Like for an example, I am having a Wi-Fi router at my home, right?
Yeah.
So my Wi-Fi router is acting as a DHCP server also.
All right.
So whenever my laptop connect with the Wi-Fi adapter, Wi-Fi, so this Wi-Fi gives me a IP address like this.
Okay.
Okay. So router will act as a DHCP server and gives IP address. Otherwise,
Mm.
we have to manually configure the IP address. All right.
Yeah.
Now, so my computer will go to NIC table and get the IP address, right?
Mm.
So are you understanding till here each and everything?
Yeah. Yeah.
All right. So you can ask me if you have doubt. Okay. Now, now, the second thing is the second field is destination IP address. Destination IP address means the IP address of your computer to whom I am pinging. So
Yeah.
my computer will get the destination IP address from command prompt. See here I'm writing each and everything. Source IP address my computer will get from routing table. Destination IP address my computer will get from CMD because in my NIC table there is no 10004, right?
Okay. Yeah.
So this thing my computer will get from CMD. My computer will go from CMD and pick this IP address and put it here in destination IP address. All right.
Yeah.
The third field will be source MAC address. Source MAC address means the MAC address of my computer. So now my computer will get the MAC address from its ARP table. ARP table is the table where MAC address and IP address mappings are saved. Okay,
Mm.
and it is there inside my computer. It is there inside my computer. So my computer will go to ARP table and tell ARP table that, hey ARP table, please give me the MAC address. So my ARP table will give me the MAC address of AA and my computer will write it in source MAC address. Alright.
All right.
Now the last field is destination MAC address. So the destination MAC address is also getting from ARP table, but now currently as this network is new network, this is a new network, no computer have communicated with each other and this is the first time I am pinging to your computer to check the connectivity. So currently there is no entry because it is fresh, it is new, right? And
Mm-hmm.
this is the very first activity which I am doing right now.
Mm-hmm.
Okay. So my computer will go to ARP table and tell, hey ARP table, please give me the IP address of 10004. So this ARP table says that, hey computer, I don't know anyone by name 10004. I don't know who is. Alright.
Mm-hmm.
Now here's the problem comes. Now my computer is not getting the MAC address of your computer, right?
No.
So what my computer will do? My computer will broadcast the message that hey, whoever is 10004, please give your MAC address.
Mm-hmm.
Alright. So now what we'll do? So in IP communication, there are three types of communication: unicast, multicast, and broadcast. Okay. Unicast means one to one, like let's say on WhatsApp. On WhatsApp,
Yeah.
I am chatting with you and you are chatting with me.
Mm.
So that is called a unicast communication. I am
Mm-hmm.
talking to you and you are replying to me. Right. The second is multicast. Multicast means let's say we have created a CCNA group on WhatsApp.
Mm.
We have created a CCNA group on WhatsApp. Okay. On WhatsApp,
Mm.
we have created the group in which I am sending an update. Okay, tomorrow the lecture is on 8 a.m. Indian timing. So everyone is replying, okay, fine, okay, 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 okay. So what is this? This is called multicast. In
Multicast.
multicast, I am talking to a group and a group of people is replying to me. Got it?
Yeah.
This is called the multicast. Now what is broadcast? In our WhatsApp, we have a feature called broadcast list. Right. Now
Mm.
what happened? In our India, we have many festivals. We have Diwali, we have Eid, we have Christmas. Okay. So we
Mm-hmm.
celebrate each and every festival and our friends are belong from different communities. So what happened whenever the Eid is coming? So I don't go personally each and every message. I created a broadcast list and I have thousands of contacts. So I added all the contact in that broadcast list and I just send a message in broadcast list that is Mubarak to all. So that message will go to each and everyone in my contact, right? And each and everyone reply back to me. Similarly, when Christmas is coming, I just write that Merry Christmas to all. So this message will go to each and every contact in my mobile phone, right?
Yeah.
So this is called the broadcast. I'm talking to everyone and everyone is replying to me. So that is called broadcast.